everybody, Brendan here with Automated Drive Systems. Today we're going to go through how to properly maintain a variable frequency drive. We have a checklist that we've prepared. If you guys are interested in the steps of it, we'll make sure we have a link down in the description of the video. Otherwise, we'll go ahead and get into it. So the drive we're working on today is a Yaskawa F7 series. This drive was installed about 6 years ago. It is a pretty good example of a standard drive that's been in industry. Not a lot of detailed maintenance has been performed on it. And like I said, we're going to go through and kind of see what we can see and show you guys how you actually should properly maintain the drives that are in your facility. So the very first thing we're going to do, obviously, is make sure that the equipment is locked out. Like I said, follow any of your company's PPE requirements as far as doing that. And then obviously the very first thing we'll do is verify that the power is dead. We've actually already done that before starting film, but we'll go through that process again. Like I said, if your facility requires PPE for this check, make sure you follow your facility's guidelines. So what we're going to do is go ahead and open the drive up, get our voltmeter, go on to AC voltage, and we'll just check our voltages. Okay. And at the bottom breaker, line to line, and we'll find the good ground, and also do a check on each line into ground. So the other critical point at this stage is if you had just powered this drive down, all drives have a DC bus circuit, and that DC bus circuit will typically have somewhere in the vicinity of 700 volts on it if it's a 480 volt drive. Certain models of drives have a LED indicator of the DC charge. Don't ever trust it. A good rule of thumb for safe practices is once you actuate the disconnect, you should wait at least 10 minutes to verify that that bus has gotten to a safe level. So in general, what we're going to do to start with, we're going to give a general visual inspection of the drive. So we're going to look at things like, do we notice any wiring that's kind of come undone? Are there any wires, control wires, power wire that have any kind of discoloration or abnormal look to them? Just kind of give the cabinet a general smell test. Are there any abnormal smells? Review the back panel. Just give the whole cabinet a once over. Make sure there's no signs of water getting in. Oils of any type. Any sort of a liquid that may have dripped, ran, splattered, or been subjected to the drive, should warrant a further investigation. What we do is take an ambient temperature reading. So what we're going to do is stand back and just kind of shoot up and get an average here with our gun. So we're right about 75 degrees Fahrenheit in this building right now. Like I said, the line isn't currently running. We'll go ahead and make a note of that. We'll take a peek at the keypad of the drive. In this configuration, the keypad's on the door. Same thing. Is there any damage to the overlay? Do any of the buttons look excessively warm? Once we're done, we'll power it up and verify that all of the digits and the buttons are actually properly working. But for now, we'll just give it a visual inspection. And the keypad condition appeared good. So since this drive wasn't running, ordinarily if you come to a drive that was in service, at this point you would record the heatsink temperature and record the volts and the amps that the drive was running at when you arrived. So the next thing we're going to do is go through and check all of the wiring connections inside the drive. So we're going to start by checking all of the control circuits. Again, verify that all your circuits are dead before doing this. And just go, take a screwdriver and just give it a little bit of a snug. Make sure there's no loose. Give a little pull test on the wire. Make sure that there's nothing loose. Between power connections and control terminal connections, having a wire come loose and create an arc event is actually one of the biggest killers of drives that we see in our business. So now what we're going to do is go ahead and take all the front covers off of the drive so that we can give a visual inspection on the capacitors, the control circuit boards, as well as check the torque on the main incoming and outcoming line connections. So now we have the drive all opened up, we've taken all the covers off of it. So the different components that we have in front of us, we have the DC bus capacitor section, we have the soft charge and the bleed off resistors for the capacitor, there's a fan carrier at the top, our gate driver board, and our control boards. This particular drive has a couple of option cards on it. So what we're going to do is continue checking all of the controls terminals, verify all the control and power connections that we can get to. Again, are snug, secure, no loose connections. We're also going to take and give a good visual inspection of all of the circuit boards. Again, looking for any signs of discoloration, especially on surface mount resistors or wire resistors, fuses that are on any of the boards. As far as the capacitors go, we're going to give them a good investigation, make sure that there's no signs of any fluid, that none of them have bulged or cracked, causing the electrolytic fluid that's inside the capacitor to leak out. If you find that, that would be a warrant for immediately taking the drive out of service and having it looked at or repairing it. But again, so we're going to look at the capacitors. What we're looking for is a nice even color. It's hard to see in the video, but there's slots here that aid in being able to see the entire cap. Up at the front, there's a vent hole on each of the capacitors. None of those vents have, they'll kind of pop out like a little tab will pop from the top. Again, we're looking for a uniform shape, uniform coloring. The older the drive, it'll probably have likely discolored, but again, you're looking for a nice uniform coloration, and then any discoloration that has taken place is uniform to the entire capacitor. So again, we're going to go through all of these connections. We're going to make sure that all of the connectors on the boards are seated well. And that all the connections are snug. So now we're going to take and check the main power connections. Again, usually what you want to do here is verify no looseness in the connection. While we're doing it, we're going to take a look at the terminal connector. Again, make sure there's no signs of discoloration and make sure that the wires are properly seated. If your installer has torque marked your equipment, a simple push test to make sure that it hasn't backed off in an inspection of the torque mark can substitute this. Otherwise, what we recommend is just give it a little snug and make sure that it's not loose. So now that we've gone through those steps, we'll update our form. So we've checked to make sure all of the mounting bolts. We've checked the cooling fan, make sure that it's visible. There's no signs of heavy buildup on the blades. We've verified that all of the internal circuit boards look good. I don't see any signs of discoloration. I don't see any signs of any liquids having come out of any of the components or having been dripped on the drive from above. Again, all of the circuit boards, capacitors look okay visually. It's hard to see on this, but back behind in the second layer of the drive is where the transistors and the diode bridges are. And visually, from what I can see, I don't see anything that looks abnormal. This is one of those sections of performing maintenance where you have to decide what the value of continuing to disassemble the drive is versus what the risk of actually damaging a component during that point in time, or introducing some new failure by not having a board seated properly or a connector seated properly. So it's our feeling, visually inspect what you can, see as much as you can, but we don't advocate actually disassembling the drive during a routine maintenance. So this will bring us to, this particular drive has an input line reactor, as what this device down here is. This particular one is an MTE brand. So same thing we've been looking for on the drive. We're going to take a look at the coils, make sure we don't see any evidence of arcing, make sure we don't see any evidence of any liquids. Then we're going to just verify that all of the connections are snug. So next thing we're going to do is do an input and an output check on the drive. For the input of most drives, this particular model is a diode-based front end. Some drives are an SCR type front end, and they'll have a different set of readings. But for today's demonstration, we're going to do it on this drive. So in order to do this test, you need to have a meter that's capable of a diode check function. So on this particular meter that I have here, you have the diode symbol, so we're going to put it in and we have to press the blue button to get a diode check. In order to run this check on a drive, you have to have a drive that has both your DC minus and your DC positive from your DC bus available to you. Smaller drives, generally micro drives, 25 horsepower or so in that range, they may not have the terminals for plus and minus brought out to an accessible location. So obviously if you don't have access to those terminals, you can't perform this test. So for those of you that aren't familiar with doing a diode test, basically what we're looking for is the meter to pass in one direction, and an ideal diode would give you a value of about 0.4. And then when we reverse the leads on the same connection, we want to see the block. So we want to see an OL reading and that there's no circuit when it tries to pass power the other direction. So I'm going to start with my red lead on the minus terminal of the drive. And I'm going to go down here to L1, and I touch it on, and you see I get 0.939, so again, that's pretty good for a diode. With 0.4 would be theoretical ideal. Again, 0.396, and 0.3 or 0.416 on this one. So again, they're all pretty close, and they're around the 0.4. It varies by drive. The big portion of this is if you do the same drive year over year, you should be concerned if you see any sort of major swing and change in this value from one maintenance cycle to the next. So now what I'm going to do is just swap the leads on my probe. I'm going to go with the black on the minus terminal, and I'm going to come across. So what you'll see is a value that slowly builds. So with this size of a drive, my meter is basically charging up the DC bus. So as long as we see it continue to rise, we can treat that as an OL reading. We can go to the next phase, and it should pick up pretty close to where it just was. So again, it's in the 2 point something, it's continuing to climb. So that one is still good. And we'll come across the other one, and again, same thing, it picked up roughly where it was and continued to rise. So now what I'm going to do is move my probe to the plus side, and I'm going to perform the same checks across. So I get 0.4, 0.403, and 0.411. So that would be the pass side. So now I'm going to switch my probes, and now I should have the OL or the climb. So I'm at 2. That looks good. We got 2.3. That came back good. And 2.5 came back good. So if you ever get a 0 and a tone, depending on your meter, that would indicate that you have a shorted open diode condition. Again, it'd be more take the drive out of service immediately and have it repaired. So the next test that we're going to perform is we're going to run the same checks on the output section. So for this test, we're not actually technically checking the transistors themselves, but what we're checking is there's a flyback diode across the transistor connection, and so we're going to test that, basically the same test, and usually what will happen is as the transistor degrades, that diode will degrade, and for sure once a transistor fails, that flyback diode is usually either damaged or the short that's created in the transistor will produce an abnormal reading. So we're going to start with our red on the minus again. We'll go to our output. We get a 0.23, 0.23, 0.23. We're going to switch our probes. Perform the same test. We get a value that's climbing. We're at 1, still at 1, still at 1. So again, that side shows normal. So now I'm going to adjust my probes. Black on plus. Come across. 0.232. 0.232. 0.233. So those show as a diode passing in one direction. We're going to switch our probes. And now we should have our climbing. So 1.3. Picking up 1.6. And 1.8. So that test verifies that the diode and the transistor bank in this particular drive appear in perfectly good condition, quite healthy. So the next thing what we're going to do is read across the positive and the negative resistance of our DC bus. And in there, I'm going to have to go for this guy. Especially on this one, we're getting about 460k ohm. So that would be pretty representative of the soft charge resistor. I'd have to pull manual for this one. We should get 150 watt, 2.5 2.2K, so that was a, that's just one more time, 2.5K, yeah, she's probably reading through another resistor on that. What you're looking for is to make sure that obviously it's not shorted. So this particular drive actually does have a DC bus fuse present. So what we'll do is take our probes, come back in and get on that guy, top and bottom, and verify at 0.5 so that fuse is still good. Okay, so now that we have verified our control circuit and we verified our input and our output section, the last check we're going to do before we get into the cleaning portion of the maintenance is just do a line to ground check on the inputs and the outputs. So it's a simple resistance check, looking for an abnormal reading to ground. So we got a good no connection there, no connection there, no connection there, and we'll do the same to the output section. Nothing, nothing, nothing. So on this portion of the test, sometimes people will take a ohm reading from line to line. On the motor side, generally, especially if it's a Y-connected motor, the motor will actually appear with an ohm test as a direct short. And that is okay. That's how a motor is designed to work. Again, it's not something you should be alarmed at if you take that measurement. And then on the input side, if you do line to line, you may also likely find two of them would also maybe show as a really low resistance or potentially appear as a short, 0.5 ohm or less. And again, generally what that'll be is somewhere ahead of the drive, there's a tapped off control power transformer. So again, a transformer will present just like a motor, and if you do an ohm reading line to line, it's okay to get a very low reading. That's not abnormal. If you ever get a reading line to ground that indicates a connection on input or output, that should be something that definitely warrants further examination. So now what we're going to do, now that we've made our connections, we verified there's no loose connections, we visually inspected the drive, the next part is actually probably one of the most critical portions of doing the maintenance. Variable frequency drives are electronic equipment. The cleaner and the cooler we can keep them, the longer they're going to last for us. We get calls a lot where cooling fans have locked up, where the drive just gets so caked with dirt over a period of time that the heatsink can no longer keep itself cool. Some really basic, vacuuming it out, light air compressor use, blowing the dust off, keeping things clean, keeping things cool, really help ensure a good long life for your drive. A couple keynotes, as far as using a vacuum cleaner, we always recommend that you use an ESD safe vacuum cleaner, especially if you're going to vacuum anywhere on any of the boards. So the one we use is a 3M brand, and it is an ESD safe vacuum cleaner. And then as far as using compressed air, you always start at the top of the drive, work your way down, dust falls, and you don't want to be using 100 psi plus plant air. If you're going to use an air compressor to blow a drive out, ideally you'd want to be 40, 50 psi, for sure 60 psi is an absolute max. We're trying to blow the loose dust off, we're not trying to blow components out of the drive. So again, what I'm going to do now is I'm just going to start with the air compressor, start at the top of the drive, lightly blow it out, get as much of the dirt moving downward as I can, and then anything that's still left, I'll take our ESD vacuum cleaner to, and try and get as much of the dust and dirt out of this drive as you possibly can. Okay, so now that we've blown a lot of the loose dust from the top of the drive down towards the bottom, we've given it a little bit of time, let some of that dust settle in the lower sections. The primary thing we're trying to do with the air is loosen up the debris and get debris that's on crevices of wires or in very difficult places to reach down and out, so we have the highest likelihood of getting them picked out of the drive. So it's probably hard to see on the video, but you'll notice there's quite a bit more debris in the bottom of this cabinet now that I've flushed quite a bit of it back. So now what we're going to do is actually work our way backwards up the drive with the vacuum cleaner and pick out anything that we can see. Again, this is an ESD safe vacuum cleaner, specifically really especially for whenever we're going to vacuum anything that's inside of the drive or a braking package. Vacuumed the entire cabinet out. This particular drive is actually in really good shape. Sometimes if the drive hasn't been repaired or the drive hasn't been maintained in quite a while, it's not that common to have some dirt and grime that's left behind that won't come off with the vacuum or the air compressor. If you encounter that in your piece of equipment, our recommendation would be to lightly brush it off with whatever, a rag or something. Don't use water. Just use a nice, like a terry cloth or a microfiber cloth, dry only, and then just lightly, kind of very gently rub where you can and where it's safe to try and remove any cake debris. If it's been numerous years or decades since the equipment was maintained, you may not be able to get it fully clean, but trust me, you're still doing a great deal of good, and you're really helping the equipment out by trying to clean anything that you possibly can out of it. So now we're back here, we have the drive all buttoned up, we've put all the covers back on. Anything, like I said, that I found that had any little bit of residual dirt, did a quick wipe down on it. This particular drive is set up with the heatsink through the back configuration. So that allows the drive to split the heat load between the cabinet and the external ambient area. So for this guy, if the drive is a standard cabinet mount, you have to perform this procedure from the inside. And if you're doing it within a cabinet, the best practice is to take air from the bottom, blow up the heatsink, and then have a vacuum at the top to capture any dust. So with the installation environment of this one, I have to kind of fit behind the machine. So it's not practical to have both the vacuum and the air compressor. So the most important part is to get the dust and dirt out from the heatsink and get that area as clean as we possibly can. So what I'm going to do is go around to the back of the drive, reach back there as best I can with the air compressor. And again, the key thing here is you want to have low pressure. You don't want to be 100 psi. You always want to blow from the bottom of the drive and force the air and the dirt up the heatsink as the cooling fans usually would. So now on the heatsink, I'm going to take a rag and I'm just going to wipe down everything that I possibly can. As a final step for the heatsink, after I've blown the air up through the back, so I'm going to take the vacuum and just run it along the very top of the heatsink to pick up any of the dust that has settled back down on the drive. So now that we've gotten the heatsink cleaned up as best as we possibly can, you'll notice there's a huge difference in the before and after with just a very simple maintenance. The last item that we have on this drive is to clean the top of it. This particular drive has a resistor bank for dynamic braking. So we'll get a ladder, get up there and blow all of the dust out of that. And then we're also going to remove these covers for the fans and get the fan and filter for the cabinet cleaned out as best we can. On these, once they're removed, you can use a higher pressure air to make sure they get as clean as possible. So now here we are, we've completed the maintenance. We've got the exterior of the drive completely wiped down. It actually looks about as good as it did the day it went in. If you have any questions about this, you can feel free to contact us at any time. We never charge for telephone tech support, 402-858-5560, or you can find us on the web at www.automatedDrives.com. Thank you for watching and have a great day.